Hi everyone, I am Parth Ghadiya, currently pursuing Masters in Construction Engineering and Management at CEPT University. Welcome to my portfolio presentation where I will talk to you through a live ultra luxurious residential project and share some key technical learnings across the site layout planning, linear responsibility chart, quality control lab and earned value management. This studio I work on the Greenfield high-rise residential project and ultra-luxurious complex consists of the 3 towers and the 37 floors. Located in the Ahmedabad, the project consists of the 102 exclusive apartments, one per floor offering the 360-degree view. The total height of the building is 131 meter. It's 1.4 times taller than the Statue of Liberty with stunning landscaping as well as the amenities. The total project cost 188 100.51 crore and the project commencement date is 29 January 2024 and the completion date of the project is 31st May 2027. The contractor is responsible for core and shell, MBPF as well as the finishing work. We observed that during the normal hours 187 to 220 laborers are on located on a site while the peak hours is the 300 workers are working on a site. Moving to the site layout planning, here we analyze existing site layout. It includes all the key facilities such as the tower zone, staff offices, scrap yard, steel yard, and the safety cabins. Mentioning further point into the site layout is there were only one entry and exit for material loading and unloading vehicular movement as well as the staff and worker entrance. After we identify 43 risks in the different category like construction, safety, quality, and the site layout, etc. But I want to highlight four risks which come under the site layout planning. First is the area constraint, improper placement of the utility lines, insufficient management of the scrapyard, and the not sufficient space for pedestrian as well as the vehicular movement. Area constraint on a site, that particular risk can be mitigated by accurate planning of the area utilization. Next is a major risk among four of them is insufficient management of the scrapyard can lead less recycle as well as the less scrap management. This can also mitigated by the segregating all the material by its category like store reinforcement bars as per the diameter. All the shuttering material can be stored separately from the other material. As we can see from the existing site layout, very less vehicular movement in the project site can be mitigated, proposing another entry and exit for the better loading and unloading for the material as well as the better vehicular movement. Moving to the layout of the labor colony. This is the detailed layout plan for the labor colony, which is the 175-meter away from the project site. As I mentioned earlier, due to limited space on a site, the curing tank and the QC lab were situated in the labor colony. After, based on the identification of the risks and the using of the risk matrix, prepare the proposed site layout, introduce the new entry and exit for the transmitter as well as the other material loading and unloading, and entrance for the staff and the labor. As I mentioned earlier, there is a no dedicated space for the scrap. So the designated area for the scrap storage and improving the better scrap management as well as the space utilization in the site. Moving to the next topic, linear responsibility chart. The detailed contractor organization chart helped me to understand the site hierarchy. From the head office, I address the flow across the planning, execution, MEPF, quality, environment, health and safety, admin, and the billing department. It clearly outlining responsibility, ensuring accountability at every level. Similar way, I prepare the on-site organization chart. Project coordinator manages 3 to 4 projects at the same time, but project manager look this particular project on a one time. Similarly, organization chart of the on-site divide into the several department as head office. Here are the blue color are showing the people working at a corporate level and the gray color showing the people working on a site. This is the detailed linear responsibility chart. The linear responsibility chart break down activity during pre-construction, during construction, and the post-construction. It highlights the involvement of the client, architect, structural, MBPF consultant, contractor from HO and contractor, and as well as the third party in the different activity. For example, preparation of the QA/QC plan is the actual responsibility of the quality control head from the head office. Preparation of the building specification, which is the actual responsibility of the architect. Next important activity related to establishment of the quality control lab is the actual responsibility of the lab in charge of the contractor from on-site. Similar way describe activity during construction like lab in charge have to do calibration of the all the equipment in coordination with the quality control head from on-site and the managing all the document related to quality. Environment and health and safety engineer must be do all the safety audits during the construction to ensure all the construction activity carried out according to the safety protocols. third-party quality control engineer must be carried out all the testing of the material as per the client requirement. Similar way, during post-construction, handing over certificate to the contractor of the carried out work is the actual responsibility of the project manager from the client side. This particular tool helping the identifying role overlaps and the area needing to better coordination. Moving to the next topic, quality control laboratory. Here is the flow chart of the people are associated the work related to quality on site. One QC engineer, one lab in charge, and the one lab technician appointed by the contractor for the checking and ensuring the quality related work on site. Project manager and the project coordinator do the final check of the quality documents. Moving to the layout of the quality lab. Total area of the quality lab is 26.6 square meter. As I mentioned earlier, the quality control lab situated in the labor colony, which is the 175-meter away from the project site. Here are the 3D isometric view of the quality control lab. This table showing list of testing equipment available on site with a specification. The on-site lab performed key material tests like cube strength, slump cone, and the concrete temperature check. We documented existing equipment from the concrete testing machine to the vibrating table, slump cone, cube molds, weighing balance, and the rapid moisture meter. For the proposed quality control lab layout, identify all the equipment on a site and compared with the standard guideline of the CPWD and the NABL standards. We found a gap like the absence of the many equipment and proper storage area for the casted cube. So based on that, we propose in the quality control lab layout in which provide the proper casted area for the cube and the increasing area for the quality control lab according to the proposed new equipments. Moving to the unvalue management. As we know that the unvalue management is the very important tool which used for the project tracking. For the tracking project, we apply the unvalue management using the both Microsoft project and the Primavera. We analyze the two specific activity, pore B of the third floor and the pore A of the fourth floor. So for the 2 week look ahead plan, we consider 31st March 2025 to the 14th April 2025. So in MSP, prepare the resource sheet. After that, did resource leveling and the allocation in each and every activity. Last step before the unvalue management analysis, set baseline for the 2 week look ahead plan. Here is the unvalue management terms. Budgeted cost of the work schedule, budgeted cost of the work performed, actual cost of the work performed, schedule variance, schedule cost, schedule performance index, and the cost performance index. Here we clearly see that the unvalue management analysis did in the Microsoft project. As I mentioned in the previous slide, for the earned value management, we considered Microsoft project and the Primavera. Similarly, assign resource in the Primavera, maintain baseline and the set baseline for the EVM analysis. This is the S curve showing the variation of the budgeted cost and the actual cost during the baseline. Here is the comparison of the both software, Microsoft project and the Primavera. We clearly see that the Pore B had the perfect CPI and SPI value 1, meaning that that particular pore B is on time and on budget. But pore A show the delay and the cost overrun, which a CPI value of 0.95 and the SPI value of 0.76. This particular unvalue management highlight the importance of the continuous monitoring and gave us the early warning sign of the corrective actions. Moving to the key learnings. From the site layout planning taught me how logistics directly impact to the safety and efficiency, and the proper site layout increasing the working efficiency and less hazard situation on a site. And preparing the linear responsibility chart show the how the particular roles distributed for the collaboration and accountability. Quality control lab study the how emphasize the importance of the proper lab setup, documentation, and the compliance with all the quality standard. And the EVM analysis to be performed, how powerful tool for the tracking for the project health and tracking the proactive steps. We do more corrective activities for the delay and the cost on construction activity. Thank you for watching.